Ever wondered what the future of transportation might look like? Will it be flying cars, teleportation, or something else entirely? As we stand on the brink of a revolution in mobility, we find ourselves peering into an exhilarating landscape where science fiction meets reality. Imagine hurtling through a vacuum tube at breathtaking speeds or levitating on a cushion of air, propelled by the power of magnetism. Welcome to the era of hyperloops and quantum maglev trains. These aren't just whimsical ideas from a sci-fi novel, but tangible technologies that are being developed and tested as we speak. But behind these fascinating concepts lies a world of complex calculations and scientific equations. These equations, like the renowned McGinty Equation and its modifications, are the unsung heroes, the silent powerhouses that are shaping the future of transportation. They are the keys that unlock the doors to our future. To answer these questions, we need to understand the McGinty Equation and its modifications. The McGinty Equation might sound intimidating, but don't worry, we'll break it down into digestible bits. First, let's start with the simplified version. Piece t equals sign piece qft xt plus piece fractal xt dmqs. Here, piece xt represents the quantum state at a given time and position. The psqft xt part is the solution of the free quantum field theory. It's like the basic framework that we start with. The piece fractal xt dmqs is the fractal potential, which introduces complexity and self-similarity into the equation. Now, the McGinty equation also has a modified version, piece xt equals sign piece qft xt plus piece fractal xt dmqs plus ps gravity xtg. This version includes piece gravity xtg, representing the perturbative effects of gravity on the quantum field. The g here is a parameter that characterizes the strength of the gravitational force. It's like adding an extra layer of reality to our original equation, acknowledging that gravity has a role to play in the quantum field. The fractal potential term Vyet in the equation has a self-similar fractal structure. It's like a pattern repeating over and over again, but at different scales. This is described by the constant parameters V0, L, and S. To derive the fractal correction term, we use integral calculus, Laplace transform, and the convolution theorem. It's like using different tools in a toolbox to refine and adjust our equation. So the McGinty equation, in both its simplified and modified forms, is a powerful tool in quantum field theory and mechanical systems. It's a mathematical expression that helps us understand and predict how quantum fields behave, taking into account the complex, self-similar nature of quantum phenomena and the influence of gravity. It's like having a roadmap that guides us in the often counterintuitive world of quantum mechanics. Now that we've demystified the McGinty equation, let's see how it applies to transportation technologies. Imagine traveling at the speed of a plane, but on land. That's what the Hyperloop promises. Welcome to the future, where travel is reinvented. The Hyperloop, a concept that sounds like it's straight out of a sci-fi movie, is rapidly becoming a reality. But what exactly is it? It's a high-speed transport system that propels a pod-like vehicle through a near vacuum tube at more than 700 miles per hour. Yes, you heard that right. But how does it work, you might ask? The technology behind it is truly fascinating. The Hyperloop utilizes magnetic levitation or maglev technology to eliminate friction, allowing the pods to glide at extraordinary speeds. Now here's where the McGinty equation enters our story. This equation, in its modified form, plays a crucial role in optimizing the magnetic fields used in the Hyperloop. It aids in creating a stable, efficient, and high-speed mode of transportation, making the concept of Hyperloop not just feasible, but also practical. The benefits of the Hyperloop extend far beyond its incredible speed. It's expected to be 2 to 3 times faster than the fastest high-speed rail, and 10 to 15 times faster than traditional rail. The Hyperloop is also a green technology. It's designed to be self-powering and carbon-free, running entirely on renewable energy. This makes the Hyperloop not just a revolution in transportation, but also a solution to some of our most pressing environmental challenges. But the Hyperloop is more than just a technological marvel. It's a vision of a future where distances shrink, cities grow closer, and the world becomes a little smaller. It's a future where we can live in one city, work in another, and still be home in time for dinner. It's the promise of a new era of high-speed, sustainable, and efficient travel. The Hyperloop certainly seems like a game changer, but it's not the only groundbreaking transportation technology on the horizon. Let's levitate into the future with quantum maglev trains. These are not your average locomotives. These are the epitome of cutting-edge technology, merging the realms of quantum physics and transportation. The maglev in quantum maglev trains stands for magnetic levitation. This technology allows the train to hover above the tracks, eliminating friction and enabling incredibly high speeds. But where does the quantum part come in, you might ask? That's where the McGinty equation and its modifications steal the spotlight. The McGinty equation, in its simplest form, is a mathematical description of quantum field theory, which is essentially the science of very small particles. This equation was further modified to account for the effects of gravity, and these modifications are instrumental in the development of quantum maglev trains. These trains utilize the principles of quantum locking or flux spinning, a phenomenon where a superconductor is cooled to a very low temperature and then placed in a magnetic field. The superconductor locks in the magnetic field, causing it to hover or levitate. This is the magic behind the levitating trains, made possible by the McGinty equation and its modifications. The potential impact of quantum maglev trains is enormous. They promise to revolutionize our transportation systems, offering high-speed, efficient, and sustainable travel. Imagine cruising at lightning-fast speeds, levitating above the ground, all while leaving a minimal carbon footprint. It's a vision of the future that's both exciting and eco-friendly. Moreover, the development of these trains could open up a plethora of opportunities for research and innovation in various fields, from physics and engineering to environmental sciences. The future of transportation, it would seem, is not just about getting from point A to point B, it's about doing so in the most efficient, sustainable, and technologically advanced way possible. With Hyperloop and quantum maglev trains, the future of transportation certainly looks exciting. So, are you ready to embrace the future?